Okay, so in this first step here, I'm just writing down all my givens, my mass, my velocity, and the height. And then I'm going to draw a quick diagram where we have the ball bouncing down from a height of 1.5 meters and then bouncing up. And it's really important to remember that these velocities will have different directions. Now, in order to find impulse, we're going to need to use the impulse equation, which is delta P is equal to mass, and then in brackets the final velocity, subtract the initial velocity. Now the first problem we're going to run into with this question is that we do not have the initial velocity. Now in order to find that initial velocity, what we're going to do is we are going to use the gravitational potential energy equation of mg delta y, because we can find what the gravitational potential energy is at the top when the ball is initially dropped. So when we solve for that, we end up getting 3.67 joules. Now at this point you might be wondering why we found the gravitational potential energy at the top, but what we know is that energy is conserved, and therefore the gravitational potential energy at the top is equal to the kinetic energy at the bottom, or our reference level, where the ball hits the ground. So when we use the kinetic energy equation and sub in what we know to be the kinetic energy, we solve for velocity, and we end up getting 5.4 meters per second. Now that we have all the variables for our impulse equation, we just sub in the mass, the final velocity, and the initial velocity, and solve. So for this question, part B, they're asking for the amount of time the ball is in contact with the floor. So from part A, we have the impulse, 2.4 newtons per second, and we're given the force the floor applies onto the ball. So all we have to do is sub it into our impulse equation and solve for t.